Now that we've shown how to roll a six-sided die by producing a random number from 1 through 6, we're going to use that same calculation again in an application that rolls a die 60 million times to show you that each of the 6 values occurs approximately 10 million times in those 60 million rolls. And that's important in a random number simulation type of program or a game simulation. You want the numbers to be distributed properly for whatever type of sequence you're trying to produce. So I'm going to look at the roll die program in the fig07_07 folder. And when I open that up, you'll see here that we've declared 6 frequency counter variables, and we'll use a little switch statement to help us count the frequency of the 1s, 2s, 3s, 4s, 5s, and 6s that are produced. Of course, we start by creating a random object called random numbers. In this case, it's a new random object. And by the way, often when you're testing a program that does simulation, you need a repeatable set of quote-unquote random values so that you can test and make sure everything is working first before you go about randomizing the program and putting it into production. So it turns out that one of the things you can do with the random class is provide an argument to the random constructor, which is the so-called seed value for the random number generator. And if you always use the same seed, you'll always get the same set of random values every time you run the program. And that can be useful for testing and debugging purposes. So before I take a look at the rest of the code here, let's go ahead and run this program. And it does take a few seconds to generate the 60 million random values. And as soon as it's done, we display this little table here with the face values from 1 through 6 and the number of occurrences of each face in this execution of the program. And you can see here that each of the values produced is very close to 10 million in this case. And I'll leave that up on the screen and go ahead and run the program again so that we can take a look at 2 sets of output next to one another. And here you can see that the outputs are different, but once again, they're all relatively close to 10 million. And when we roll a six-sided die that many times, we expect to get approximately 10 million of each face. It's generally not going to be exactly 10 million of each face because in any given roll, we don't know what value we're going to get. Technically, we could get 60 million ones, although that's highly unlikely. So let's take a look at the code that produced that output. Again, we started with 6 counters, all initialized to 0 because we haven't rolled the dice yet. Then we have a for loop that's going to roll 60 million times. So you can see here counting from 1 to 60 million. And during each iteration of the loop, we're going to assign to the local variable face the result of the same method call that we looked at in the preceding example, producing random integers from 1 up to but not including 7. Now, based on the value in each case, we're going to use this switch statement to figure out which of the frequency counters to increment. So you can see cases 1 through 6. We didn't provide a default case here because we know that the statement up above is only ever going to produce the values from 1 through 6. So the switch statement summarizes those, and when we get into the next lesson and take a look at arrays, we'll see another version of this same program that collapses all of the code in lines 24 through 44 into a single statement using a so-called array data structure. Now, once we're done summarizing those 60 million rolls of the dice, we use some console.writeLine statements to output the values. And you can see here that we're producing 2 columns of information, one with the heading face, followed by a tab character, and then one with the heading frequency. So \T is the escape sequence that represents the tab character. And at line 48, we then display the face 1, followed by a tab character, and we use a string interpolation expression here to insert the value of frequency 1 into the interpolated string. We followed that with a new line character, then we display the value 2 followed by a tab and the value of frequency 2, and we do the same thing here in lines 49 and 50 for the values of the faces 3, 4, 5, and 6 as well. In the next program, we're going to take these random number simulation techniques that we just introduced, and we're going to implement the dice game called Craps.